Hi, my name is Susan Wu. Thanks for staying back on Friday to hear from us. I'm Susan Wu. I'm I'm a product manager in Google Cloud. I focus on cloud networking, GKE networking, network security. We all wear a lot of hats here at Google. Thank you. So with me, I have my panel, esteemed panel. We're talking about extending Kubernetes for AI. So come on up. Yeah. Thank you very much. We have no walk-on music. Thank you. So with that, I'm going to let the panelists introduce themselves. They're all mic'd up and ready.
Cool. Thank you. Hi, my name is Etienne, co-founder and CTO of Weaviate. Weaviate is a vector database company, or actually it's more of an AI data platform these days, but it started out as a vector database company. And of course, we run a lot of AI workloads on Kubernetes.
Hi, I'm the only one who wasn't mic'd up. We ran out of packs. But my name's Lucy. I'm an engineer at Uber, where I work on our platforms. We have a quite substantial presence on Kubernetes. We're one of the biggest end-user deployments in the world, which I'm sure we can get into later. And then we run a mix of AI/ML workloads, both for training and for inference across non-critical stuff, but also in the core trip flow of Uber.
Good morning, everyone. My name is Andrea. I work for a company called Overstory. We do vegetation management using satellite images. Basically, we use satellite images to prevent wildfires. And I'm here today to talk about how we use Kubernetes in the cloud, in Google Cloud, to make sure all of our clients get their risk assessment on time using our platform.
I'm Tim Wickberg. I'm the Chief Technical Officer for SchedMD. We're the principal Slurm developers. Also now the developers of Slinky, which is meant to be our set of integrations for bringing Slurm's scheduling wherewithal into the Kubernetes stack.
Okay. I got a couple of prepared questions, but at some point I'll have folks come on to the microphone and you can ask your questions directly. So starting with Lucy, for platform engineers or infrastructure engineers, do you typically provide Kubernetes clusters for sort of conventional microservices orchestration, or do you have dedicated teams for AI/ML workloads?
So our approach is that we don't... Bad time for a cough. Our approach is that we don't directly offer what I would call maybe Kubernetes as a service. Our worry is that it's very expansive and it's very powerful, but at the same time it leaves you with very little guardrails to do things maybe the way we want. We want you to do rollouts and deployments in a safe way. We want you to do them within at least some safeguards that we as a company have. So we run a stateless compute platform that users actually deploy their services through, and that gives them a lot of stuff for free, safe rollouts, safe deployment, safe CD. Our AI/ML workloads are then actually built on top of that. There's a whole team of engineers who build the platform for folks to deploy things like pipelines and training jobs and etc. That is then also wrapped in a little bit more opinionation in that you have to get your data source from certain places, etc. I'd say I think we have, so I work in Denmark, and in our office we do nothing but build platforms, and we have about 140 people in that office, plus probably like maybe another 20 plus working on AI/ML in the US, plus another maybe 10 plus 10 plus scattered around the world as well. But yeah, it's a pretty substantial presence of engineers just working on these internal developer platforms.
Do other folks want to weigh in?
Yeah, I'd be happy to go because there's a nice contrast. I think like 140 people, that's more than our entire company. We do have a platform team as well, but from our perspective, the platform team is more about provisioning the Weaviate database for our customers. So it's essentially, you could say the platform team is what runs our SaaS. So in that sense, it's not so much an internal team catering to different teams with different workloads, but it's very much a specialized platform team that really just, and it's a bit oversimplified in saying it just runs the Weaviate database, because of course there's so many other things that come with it, be it observability, and then if we're talking AI and GPUs, there's different observability loads as well. But it gives the team much more of a focus compared to just any AI workload popping up anywhere in the company.
Yeah, just wanted to add, it's actually very interesting. It's a point that I've been hearing about more and more over the last couple of days, that the concept of like platform engineering and platform team changes a lot. So of course, like platform engineering in Uber is different than the one in Weaviate, and it's different than the one that we have at Overstory, which is a much smaller startup. And so it's also the task of the company and the team to adapt to what are the use cases of the business to build a platform team that fits the company rather than a company that fits the platform team. That doesn't really work, right?
Tim, did you want to?
No, I don't have much to contribute there. I guess we're a tooling vendor at our heart, so we don't actually have our own platforms to maintain, fortunately.
Okay. Actually, we're talking about customization, extending Kubernetes. So maybe starting with Andrea, what kind of customizations have you seen, that people have been doing? And if you have any adjacent projects that you've seen people bring in to Kubernetes, feel free to talk about that as well as they build out the data pipeline.
Yeah, absolutely. So as I was mentioning before, what we do in Overstory is vegetation management. So basically what we do is that we get satellite images from satellite provider like Airbus or Maxar and so on. And basically we merge that information with information that we get from a utility provider, basically the folks that bring energy and electricity to your homes. So we combine these two types of data and we create a risk profile. The idea is that from satellite images, we can look at where high tension power lines are going through, so where they go through a forest or through cities. And whenever the vegetation gets too close to the power line, we can notify the energy provider so they can go and trim the vegetation before a wildfire spreads out. Wildfire are a massively destructive event. They bring a lot of damage to our community, to people's life and businesses. And so we are working towards preventing them rather than reacting to them.
Yeah, thank you. We kind of need that in the U.S.
The U.S. is indeed like a big, many companies in the U.S. are customers of us just because the land is very vast. One thing that I wanted to add that I will talk more about this right after lunch. I have a session dedicated to how we do and that we try to handle these problems at Overstory. So in case you're interested, I have a talk later today right after lunch at level 0, room J, where I will talk specifically on how we tackle these problems. But just to give you like a brief intro, or I guess you can call it spoiler, we use Google Cloud. Specifically, we use a combination of GKE and Google Cloud Run. GKE has been extremely useful for our type of use cases. Satellite images come in all kinds of shapes and forms and resolution. We use resolutions up to 15 centimeters. So that's very high resolution, high imagery. And the flexibility that we get with Kubernetes and having the possibility of having workloads that use 1 CPU and 2 gigs of memory, or 72 CPUs and 450 gigs of memory, it's very important for us. On top of it, one of our open source projects that we use is called Dilocker. This is the tool that we use for our data workflow engine. It's an open source project that works really well in the cloud, in my opinion. I am an open source contributor of the project. I've been working with it for quite some years, since version 0 point something. And yeah, it has been really exciting to see this project grow, add more integrations with Google Cloud as well, and with Kubernetes especially.
Well, this is great. Thank you for a nice plug for both GKE and Cloud Run. But this is definitely not only, we have other upstream Kubernetes at Uber and other forms of Kubernetes. So it's not really a vendor pitch or anything like that. But thank you. So we talked a lot about, kind of workload placement and dynamic resource allocation in this conference. So, especially the DRA is a beta feature in Kubernetes. So what are some of the advancements that you're seeing in resource allocation or workload placements? I'm going to start with Tim on that one.
I've probably been at a half a dozen talks on DRA in the past couple of days at least. I think DRA does start introducing a lot of really interesting capabilities to make sure that you can start doing very, very fine-grained allocation of resources. Alongside that, one of the things that I'm here pushing for this week is being able to do a very similar set of management tricks to CPUs. And then building off of that combination of fine-grained resource management to start talking about copying that same pattern across multiple nodes. And maybe that there are some missing primitives to better help enable multi-node AI training workloads with a very long-term strategy towards being able to natively process training, which is generally being done on just Slurm on bare metal today, but maybe it can be done on Kubernetes on bare metal, with Slurm providing our scheduling expertise into the mix.
Yeah. If you think a dozen talks on DRA is bad, you should try being an upstream contributor. I've been on a dozen pull requests about DRA in the last month. But no, so I think I'm going to talk about something that isn't DRA for once, because I'm sure you've all heard a lot about this. One of the other things that's changing a lot, especially in the node integration of Kubernetes, and this has not been prearranged, but shameless plug, at the same time as your talk, unfortunately, I am having a talk on what I'm about to talk about. So in the latest release of Kubernetes, there's now support for in-place pod vertical scaling. Now, what does that mean? That means you can change the CPU and memory requests and limits of a pod without stopping the application. You can change it even after your pod has started running. That is particularly cool for both AIML for training. You don't have to disrupt your application. And it's also cool for batch jobs and all sorts of things in between. Also, what's changing is there's if I was to take it to a bit more of a wider angle, there's definitely a lot more of a push that pods are less cattle and more pets, especially nowadays with more advanced workloads, where maybe in the past the project has not been the best for them. I know Racelam, we very much hear the sentiment across the project about the fact that there could be better integration there, and we'll try and do more there, at least in my opinion, we will. And then, what was the other thing? Yes, and the other change that's coming that is also quite useful here is pod-level resources. You can share your resources among multiple containers in the same pod, which before, of course, you had to define your resources at a per-container level. That is quite useful. You can balance resources across a single C group, across multiple containers that are part of the same training workload. Obviously, that's not everything. I think that, for example, we need to think a lot more maybe in the project about, if I'm thinking AIML, maybe multi-node inference. It's not particularly the funnest thing in Kubernetes to do today, especially if you have multiple pods that you have to kind of keep together, kind of are related, but Kubernetes doesn't really treat them in a related way. But yeah, there's a lot coming, I think, in advancements 2K itself on this.
Lucy, aren't you doing a talk in the afternoon?
At the same time as Andrea's talk, so
you can plug
make your choice.
Actually, we talked a lot about running Kubernetes for AI. Etienne, can you talk about some of the characteristics? Is it kind of like a constant volume, or is it very bursty? And how does multi-tenancy play into this picture?
Yeah, so we definitely see both. Maybe just to quickly start with what Lucy just said about the ability to change pods that are already running. That is sort of the first category of three categories that we see, because Weaviate is a database. Database is a stateful load. Stateful loads on Kubernetes is something that 5 years ago people would have said, you're crazy. I'm sure these days a lot of people still think so, but it's fewer and more people are doing it just because the flexibility in general gives us so much value. But yeah, a stateful load, and then specifically for vector databases, you can almost think of them as in-memory databases for many cases, and that just, you're essentially bound by whatever throughput you have from your disk at startup time to just load that all back into memory. And as loads grow, there's only so much that you can scale horizontally. So the ability to basically vertically change a pod, that is a way of bursting, I would say, just the workload growing and shrinking. And then, of course, in a multi-tenant environment, if you have so much physical infrastructure, so many nodes, you can share that across these. If we can share that more dynamically without introducing a restart, that's going to be a game changer for databases. The other two categories that we have is more thinking of, probably when people think of AI workloads, they think more of GPUs. And there we have two. One is the embedding creation. So Weaviate being a vector database, you can think of this very roughly as you have any kind of multimodal data, you throw it into a model, that model spits out vector embeddings, and those vector embeddings are what's actually indexed in the database. So what that means is even if that indexation part is CPU based, you still need the model to create those vector embeddings, and you need them. You need a lot of them at ingest time, because most people do bulk ingests and then updates. But you also need them at query time, because at query time, same thing, you query in some kind of modality, typically text, can also be images, can be sound. That needs to be translated into this essentially array of numbers again. And for this, we're running what we call the Weaviate embedding service, which is essentially just this. It's a media to vector service, and that runs on Kubernetes in sort of various pods that have GPUs attached to them. And there we're controlling the burstiness through multi-tenancy. So this is a multi-tenant service. And of course, you still have peaks around specific hours or so. So one of our customers is an email client, for example. So there's very clear distribution of Monday morning, 9 a.m., you get so many emails. And that is something that you can plan for, and you can sort of scale dynamically. But then we also have, and that's the third bucket, extremely unpredictable and bursty loads, where, for example, one thing that we just recently introduced is called the transformation agent, and that's essentially a AI agent that runs on your data, and you can essentially kick a transformation off with a single prompt. So you would say, like, take every single object that's in my database, translate it to Spanish, and write it back into the database. And that is extremely bursty, because you could have billions of objects, and all of a sudden, all these translations are essentially LLM model calls. And what we're doing for that is essentially the category where we said, like, we don't want to self-host this, and we're using a third-party provider, Modal in this case, who, from what I understand, do not run on Kubernetes themselves because it is so bursty, and because they really charge for CPU minutes, which is something that is great for us as a customer, but quite a bit of a challenge from an infrastructure perspective, I think.
I think, Andrea, you have a lot of data that you're manipulating as well. Do you want to add anything here?
Yeah, exactly. As I was saying, like satellite images, they take a lot of space, as you can imagine. So we use very large amount of storages, and this is why I'm also interested very much into the array, right? The dynamic resource allocation, because our pipelines, they always look the same, more or less, where there are a lot of choices to be made, but depending on the input that we get, the pipeline might take a lot of resources or less resources. And when you run like workload that are a little bit more stateful, that becomes a problem. You don't want your pipeline to go out of memory after processing, 12 hours, and you have no checkpointing, and all of a sudden you need to redo everything from scratch. So I'm very much looking forward to the, new changes and new features that will happen over the course of the next months and years in that regard.
One of the things that at least I'm trying to get us in a better state about is having more checkpointing and being more disruption tolerant when doing training in batch, because GPUs are, well, this is going to be a real shocker here, but GPUs are really expensive.
Yeah.
And it's unlike CPUs where, we can have a safety buffer, it's fine. It's going to cost the company some money, but it's worth it. With GPUs, ideally, I want to be using all of them all of the time to do at least something and to extract value from them, because they are worth their weight in gold. So obviously, we're never going to get to 100% utilization 100% of the time. But how can we even get close? Well, one of the ways we can do that, at least, is we will only be used. Fundamentally, a load follows a peak and valley, right? And when we are down in this valley, when we have a less load because people are sleeping, etc., well, really, we shouldn't just leave. In my opinion, we shouldn't leave these GPUs idle. We should reuse them on a workload that is more disruption tolerant. But we can very quickly take the GPUs back if we suddenly have a spike of traffic, a capacity crunch, something bad happening, right? We are not there yet. We're working a lot on this project within Uber that I won't go into the specific details of, because I did this crazy thing where I signed an NDA for money from them. But we are trying to at least get into a position where we can maximize the potential use cases that our GPUs could be used for, so that if we have a disruption-tolerant workload, we can opportunistically eat the idle capacity rather than buy more devices, because, they're really expensive.
Yeah, so this morning's keynote talked about the inference gateway, so you can kind of load balance a request to the available endpoints. So now I do have a couple questions for the panelists, but if folks can go to the microphone, you can ask individual questions. Thank you for being the first.
No problem. Yeah, it's a question about GPU management. I think I already partly know the answer from Lucy, but be interested in the rest of the panel. So do you work with a fixed pool of GPUs, or do you use the autoscaler to get them on demand, and why?
So at our scale, we can't. The question I think was, do we work with a fixed pool of GPUs, or do we use auto scaling with a cloud provider or something? Right? I see a head nodding, so I'm going to assume that was the question. So the problem we have is that at our scale, if we ask a cloud provider to hold capacity in reserve and give us a quota, they say we are not holding an entire data center hall in free capacity for you. So our GPU pool is fixed. It's a mix of on-prem GPUs. In fact, we still have some quite old ones because they're expensive now, so why not keep them and keep using them? We also have some in cloud providers, OCI, GCP. But yeah, it's a fixed amount fundamentally, and it's because of how expensive they are. Actually, if you want more GPUs and you want them outside of the shared pool, that is a process because that's a lot of money.
I just wanted to say, at scale, all resources end up being finite at some point. I think historically the cloud providers have done a great job of pretending they're infinite, and a lot of workloads have been built around this idea that they can ephemerally always pull in resources. But what you're seeing out of especially AI/ML workloads is, we do need to queue up work that can't instantaneously run. How do we start talking about deferring work? How do we prioritize work? How do we preempt work efficiently, and especially in respect to keeping system utilization high? Because idling those GPUs is quite expensive.
Yeah. And yeah, just reiterating that, at scale, cloud flexibility just disappears. It's not real.
Yeah, we found a similar thing. We used to use the autoscaler very flexibly, and then in the last year or so, the autoscaling latency is about 3 months.
Yeah, that sounds like 3 months sounds like about the lead time on this stuff, if not more.
Thanks.
Thanks.
Thanks for a question. Are there any other questions from the audience? There's no line. Okay.
That must mean that we were really good at answering everyone's
I
questions.
have a question for you, actually, Lucy. So it's a lot of times, like you said, it's a very finite resource. And so how do you make your compute choices? I know that some people are making compute choices using different variations for specialized compute. How do you do that? Or how do you choose workloads to go on which type of compute?
So we have right now it's a bit less mixed than in my opinion it should be, but fundamentally we have, and actually I'll tell this to AI/ML, when you create a service as Uber that needs to use GPUs, you specify what GPUs you actually need with gating, that it has to be done by someone who knows what they're doing. You can't just be a random engineer in an office who's got no affiliation with the AI/ML folks who just goes, I would like 100 H100s now. That is then placed onto a machine, typically on-prem, where those GPUs are available, and then eats the capacity there. Outside of that, we're trying to get better at co-location because we don't want. Fundamentally, we've at least found that co-location first off allows us to do more resource overcommitting, but the challenge there really is noisy neighbors, isolation. There's no magic bullet here. It is a really tough problem. Yes, sorry. Any specific there?
No, I think you covered it. How many cores do you run on Kubernetes out in Uber?
Okay, so on Kubernetes, so at Uber we measure things in CPU cores because it's a roughly good metric. If you measured in hosts, a host could be small, big, it's useful. CPU cores has its downsides, but it's a good enough metric, I'd say. Right now, I think we have about 4 million CPU cores on Kubernetes, and it's going to be more like 8 to 10 million within 2 years. So it's a lot. I think we're the biggest end user in the world. My only evidence for that is I have yet to meet someone who's got more. If you are an end user in this room and have more, please let me know. But yeah.
One question out in the audience. Anyone using GPUs and anyone running TPUs? Kind of interested in that. GPUs, we got a few. Okay. Are there any folks out there running GPUs at the edge? Just checking if there's any folks. Okay. Okay. I think, are there any more questions? Feel free to go to microphones. If not, the panelists will stick around for individual questions. There's somebody. He's taking. Okay. Well, thank you very much. We'll stick around for individual questions.
Thank you.
Thanks.